Hi guys, so today's tutorial is this developments question here from the Graphics in Design and Communication book on page 199. It's this question number 3, developments question. So in this question we are asked to draw the plan and elevation and complete the surface development. So it's kind of down to the basics here, drawing your front elevation of this object and then the plan along with your development itself. Okay, so I'm just going to get straight into it. You see the measurements are given here. I'll get straight into there. I'll get started on the elevation and plan, and then we'll get stuck into the development. Okay, so here we have it. I have my elevation here, as you can see, drawn here with the height of 50 millimeters were given, depth from left to right here of 40 millimeters, or width if you want to call it in that view, and a height here on this edge is 8 millimeters. So that there, given the height of 8 and the height of 50, that itself is a way of determining the angle of this cut surface of the solid. Okay, your plan view, of course, the depth of it from back to front 30 millimeters, your length here 40 millimeters, and you're given this radius of this arc from the plan view, which is 24 millimeters. Okay, so by using that radius of 24, if you take that from the 30 millimeters here, it leaves you at this point with 6 millimeters to play with, and it gives you your point here as well, of course. Okay, down there I have a little 3D graphic of it. You see the pink surface here is the cut surface, if you like, and the green shaded area here is what you see from the sides and so on. Alright, so I'm going to get started. Generally in these development questions, I like to keep my development itself on the same height, if you like, sitting on the XY line if at all possible. Now keep in mind, for your DCG exam, the questions are going to be a lot bigger than this, and they're going to be a lot more complicated too. Alright, so this is just a basic setting up of a developments question. Alright, another little thing I like to do when I'm starting out my development, I like to start off with the edge that I see here in the elevation, if at all possible. So this same shape here, the outline shape, I'm just going to start off here and draw that in my development area. Alright, so to do that I keep it on the same height as my XY line, as you can see, sitting on that. And the reason I do that is that I can simply transfer my heights across from the elevation view. Okay, so the top height there and this bottom height, so just how far across do you bring them? Well, you bring them across as far as you need them, basically. Okay, I know my depth is 40 millimeters here, so I'm going to go for this guy. I'm going to come across 40 and have that marked there, and I'm going to come up along here. Now keep in mind, this is going to be a dashed line, because it's a hinge line, as I like to call it, where it's joining on a corner. Alright, so across 40 millimeters to the next corner is this point here, and you can see that's just coming up a height of 8 millimeters. So I'm going to draw that in there, height of 8 millimeters. Alright, this angle here, keep in mind towards the end of the question we'll have to draw the true shape of this top surface. So that means it's going to be hinging. Well, the way I'm going to do it is to hinge it along this edge. So I'm going to draw that line in there as the dashed line also. Okay, and the thing with developments, as I said before, you could draw it differently as regards the layout, and still we could both have the same answer, or the correct solution. So next thing I'm going to do here is, this is the back surface of the object. So this triangle here, the back of it we cannot see. I'm going to take the easy ones first of all, and this rectangle across here, which is represented, I suppose, the left hand side as we're looking at it, that's a rectangle. We have our height already, we know the depth of it, so I'm just going to go along and set that one out at 30 millimeters back this way, and I'm going to draw that guy. Now I'm going to draw this as a heavy line. Okay, the reason I'm drawing that one as a heavy line is that I'm going to start from that point, if you like, and I'm going to work my way across here. Okay, so I'm just going to take it surface by surface, and that way you'll get through the question nicely without any real difficulty. So the next surface view look, I have this guy here, which is here. This surface at the back, we have the true shape of that guy here. The next one I want here is this guy. Now we've determined the total depth of the object is 30 millimeters minus your radius 24, so that leaves 6 millimeters. We have the height here brought across, so if I measure out 6 millimeters here, draw that line up, and again I'm going to draw the side of that dashed, and I draw the top of it in solid. Okay, again, the reason I've drawn that dashed is because I'm going to add the curved surface to that part of it. Alright, so the next part, I suppose, in this question is where the difficulty comes in. Okay, so this curve here, we need to find the length from here to here, okay, in order to get your distance across here to the other side. Alright, so I'm going to label this guy here. So if you just want to label the whole object, you probably start off labeling it all 1, 2, 3. I'm going to call this guy 4, this guy 5. Okay, no harm to get into the habit of labeling them. So this guy here, the back surface is 1, 2. And to label that over here, that'll be this guy 1 and 2. This guy is 0.3. The next one is going to be 4. And if I work my way back, here 1 over here is 5, which is this fella over here. So that kind of shows you what surface is what as you unfold this out onto a flat plane. So the next one we're working on is this guy. Now generally when you're working with these type of questions, you have an arc or a circle or a semicircle in your view. The chances are, excuse me, that you're going to have to divide it up in some way to get the points along the curve in another view. Alright, so what I've done here, from my center point, with my 30, 60 degree set square, divided that into 3 equal parts. So 30 degrees, this way at 60 degrees, and that gives me 2 more points along the curve. Okay, 2 more points. I'm just calling for all those points. We'll say point A and B. Alright, so if you imagine on the base of this guy over here, if you had 2 points, okay, I'm just going to draw that for you. So if you essentially divided that into 3, looking down on top, remember, this is what you're seeing. Divide that into 3 equal parts. This is point A, and this here is point B along the curve. Okay, essentially the reason I'm getting those is, first of all, to get the distance between them. Now this, I suppose, is an actual estimation rather than a 100% accurate calculation. You could do this mathematically to get the length of this arc from point 3 to 4, but in DCG you'll be doing it graphically, so this is the way we do it for that. Alright, so you have 3 equal spaces, depending on how you divide them out. As long as you use your 60-30 degree set square, they should be equal if you're accurate. So as long as you measure one of those, you could measure it with your set square. So from point 4 here to A, and you're looking at 13. Or if you want to do it with your compass, it's possibly more accurate and just handier for setting up. Alright, so you can see there, the distance from that, from 4 to A to B, and B to 3 is 3 equal distances. Okay, so as we're working backwards, you can imagine this guy is going to open out. I'm going from 3 to B, so that distance would be there, 3 to B, mark B, which is 3 to B, now B to A, B to A, it's 2 equal distances, and again that distance from A out to get corner 4, so that's this corner here. Alright, so if you imagine that's this corner here, and your height where corner 4 is this actual height. So if I project that height across. Okay, projected that height across like I did up here for the top height and this lower height. Okay, bring it across until it hits your line projected up from point 4 on the XY line. Okay, and that line there is the line coming up from this corner here. Point 4 is the other end of the arc. Okay, so that, in fact, depending on how you do it, I'm going to do that as a dashed line. Okay, 1, 2, 3. I'm just going to dash that line. The reason I'm going to dash that line, you know, this section here is the curved section. Okay, I'm going to dash it because this last surface here that you can see on the front, I'm going to bring it over this side. Now I could attach that on over here from the back on this side. That's entirely up to yourself, but that's what I mean about your layout. Just depends what way you decide to lay it out. Both ways will be correct. It's just depending what way you decide to lay the development itself out. Okay, so just getting back to the your points A and B. Why have I them there? So if you imagine along point A and B that they're both elements or generators on that curved surface. Okay, so they're projected straight up. That gives you points on the top cut surface here where point A and B will be. Okay, which in conjunction with that actually gives you the height along that line of point A. Okay, so taking point A, if I project point A from your plan up, and that here is to show that generator. I'll just do that dash so you can imagine that guy is this guy in your 3D view. Now I have the height of it from your XY line. I'm going to project that across here. Now this is where your labeling comes in handy. So I projected that height across. Again, that's the point A, so I come point A here on the XY line, the position of it, draw that guy up, and that gives me the exact position of point A when I have my curve drawn. Okay, same thing with point B, project it up. Bring that height across where it hits the cut surface. And again, project up from there. Alright, so there you have your 3 points there. You have point 3, which is this guy, point B up, point A is the next one, and then point 4. Okay, so I'm just going to join those freehand. Do it nice and lightly first. Join those freehand, and that will be obviously a curve. When you're satisfied that that's accurate, you can draw that in place there. Okay, if you want it to be more accurate, you could set a few more points along here and do the exact same thing, so you'd have extra elements or generators to get more points, which would in turn give you more accuracy. But as long as you have a few of those shown in the question, you've shown how you know how to do it, I suppose just make sure you put enough in rather than not enough. Alright, but that there is your curved surface, the way it's curving up. Okay, I suppose the key thing for this is to be able to picture how the whole thing is folding up and how it's fitting together. Alright, so I have one surface, which is this guy looking down on the edge view. This second one is my sloped surface here looking down the edge view. Third one is this little guy here. The fourth one is a curved surface, and now we're left with this guy. Now that one is simple enough. I already have the height of number 4. I simply need to take my distance here from the plan. That's my true distance because I'm looking down on it. Okay, that's the true distance from 4 up to number 5. Let's level those. So I'm going to set that from number 4 on the XY line. Project that height up vertically, and again the height of that is the same height as the top of the actual solid there. So projecting that across, that gives me that guy, and that's going to be drawn solid. That's number 5, going to draw that in a heavy line. Now you could say, should this one be dashed? That's a heavy line, sorry, and that's coming down to here. Alright. Now, if you look at that, you do actually have two number 5s. Why is that? Well, when you think of when this development is folded over, this surface here is going to meet with this surface on that number 5. So it's in fact, it's the same corner, but it's just the way it's presented on the development to show that. Okay. So moving on to the next step. Some of these questions may have top and bottom. We're going to assume these ones have. Okay, well it does say it's a solid, so there is a top and bottom, so I'm going to go ahead and do the development for them. The bottom itself, I'm going to again hinge. If you can see this light construction line here, I'm going to use that back edge again, which is this guy here, as the hinge line. And the bottom is quite straightforward. Okay, because you in fact already have the true shape of the bottom drawn here, which is essentially your plan view. So that in turn there is your plan view, just redrawn again, okay, to show that. I'm going to carry that rectangle down to get my center point of the arc, and again we know the arc has a radius of 24 millimeters. Just going to set that guy there. Rotate my arc, and that in turn gives me the other two corners I'm looking for. So that there is the true shape of your base, okay, which is exact same as your plan view. Alright, so that's all you need to do with that part of it. If you want to go ahead and label it here as well, but not necessary as such. I'll just write that in, that's the base. Again, no harm to label your different surfaces just so you know what they are, and it might make it easier for you to follow through. Okay, so the last one here is your top surface. Alright, so your top surface here is this pink shaded area. Okay, this is your look in your plan view. Now, neither in the plan view, in my 3D view, or the development, I'm not seeing the true shape of any of those. Okay, so like the base here, I'm going to hinge that up. So if you imagine that surface there is going to be hinged up onto this flat plane here, and this here is your hinge line. So I'm going to call this guy, what have I have A, B, so just call this C and D. So those 2 points, C and D, and you could see the same here, C and D. Okay, and in your development, this is the same 2 points, C and point D. So that's the end, both ends of that line. That's where I'm going to hinge it up from. So if you imagined that that's your hinge line of the surface itself. So just have, sorry, a piece of paper here, I'll use this as an example. If that was your hinge line and you were to rotate the hinge up, or that flat surface, which is the pink surface, it's going to be rotated like that onto the flat plane, which in turn is going to be up at 90 degrees, if you like, to that actual hinge line. So as you hinge it, comes up at 90 degrees to the hinge line. So I'm going to go ahead and draw those 90 degree lines just to get it started, okay? Okay, so what I have there now is the back end here, point C. So CD, and call this guy E, and F, this is the top surface E, and I'll call this guy F. So my distance from C to F, I know again from a plan, which is this distance here, 30 millimeters. So I can measure up 30 millimeters and just set the compass on it there, or you can measure it whatever you fancy. 30 millimeters up here, that gives me point F, and on this guy here we know 24 from 30, that gives us 6 millimeters. So just going to measure up again, as I said, you can measure it with the compass or your set square. Just going to measure up there 6 millimeters. So that's both ends of my top surface. Alright, so down to the next one. This corner G, alright, this corner G, mark it here. We know we come from C to F, C to F, now G is coming out this way. Alright, so you can see the line FG is running parallel to CD, which is this line. So I'm going to run that line parallel to CD from point F. I don't know how far yet, but I'm just going to run that line for now. Alright, so my distance now from FG, where do I find that? Alright, so FG is to be found from your other views also. Alright, so if you look at what you have, where else have you point G? Okay, if you look here from your elevation view, this is point G on the cut surface, so you can imagine that's the position of it, the height, if you like, in the elevation. That's projected across until it hits my hinge line here. So I'm simply going to project that guy out again, parallel, using the sliding sketch base, parallel, back end of it, up here, and where that crosses my previous line. Alright, she's moving. Where that crosses my previous line, that's giving me my point G. Okay, so F to G. And we're down to the last part then of getting that curve along here. Okay, so the curve between those 2 points. Okay, so as we have here, we have 2 points here. Again, on that surface of the curve, we have the heights of them projected over. So same thing again, I'm just going to project those 2 points. Again, we're all coming perpendicular to this hinge line with those points. Alright, just line that up first. Those 2 points, again, I don't know how far off yet. I'm just going to draw those lines up for now. How do I determine where on those lines those 2 points are? Okay, if you identify the hinge line from your top view here, now this is 1 and 2 because that's representing the base, but directly above it is C and D, so they're in fact corner C, corner D. Okay, what we need to get now is the distance from that hinge line out to corner A. So we can get that through distance here from your hinge line out to corner A, or sorry, out to point A. That's the true distance of it. So if I come along, measure that again, either with your compass from the hinge line to point A. This is your hinge line. Point A was followed across here. That's point A. Okay, point A. Same thing from point B. Measure that distance from point B, because that's where you're seeing the true length, the distance from your hinge line to point B. You're seeing the true length of that there. Again, from my hinge line, that line B is projected out. Got my 2 more points, and like I said previously, you could put extra points in between those. Okay, so draw in your curve, nice freehand curve, and when you're satisfied that looks right, you know, go over that a little bit heavy then. Okay, so the importance of highlighting all of those points, you know, that really makes it helpful for yourself. So I'm just going to go on ahead here, drawing the base of that, just lines heavy. And that shows all your surfaces there as it is in a development. Okay, so I'm just going to go ahead and shade in those particular surfaces, and it might give you a better view then of how it looks. Okay, so that's it folks, that's all your true surfaces here. The surface development complete, so don't forget to label your views, elevation plan, your development itself, and again keep in mind the importance of numbering and labeling each point. Alright, I have your base here left white, as we cannot see it here. That's the base, this is your top surface, and this is your front and your sides, and of course the curved surface here. So I hope that helps guys. Don't be afraid to give a thumbs up or a comment there on YouTube if you have any other questions. Thank you.